Let's do an example. Let's imagine a cone with height 5 and radius 25. So that's a fairly wide, broad kind of cone. And it's pointing up. So let's draw the situation. So we've got 5 here, and the edge of the cone goes out here to 25. And then over here to negative 25. And what else do we want to say about this? Maybe draw a differential element. We'll imagine kind of slicing it here, and there'd be a counterpart over here, and we kind of draw the three-dimensional shape as best we can. So what's the next step? Well, yeah, maybe it's good to write our generic formula. So our generic volume by shells formula. Around the y-axis. So try to write it before I write it here. That's the integral x equals a to x equals b, 2 pi x times f of x dx. And remember, what's the interpretation of those? 2 pi x is the circumference, f of x is the height, and dx is the width of the shell. All right, so what do I need to do for this problem to make it fit into this formula, if that'll work? Well, 2 I know, pi I know, x I know it's going from a to b. What is f of x? Do we have a formula for f of x here? Well, there's a few ways you could do it. You could say, what's the slope? I've got a point at 25, 0, so I could say 0 for the y value minus 5 for that y value over 25 minus 0. So that's overall negative 1/5, or you could say negative 0.2. And the y-intercept is clearly 5. So f of x equals negative 0.2x plus 5. And so that tells me f of x. That's basically all I need to fill in there. What's my starting and stopping point? So we'd say I'm starting at 0 with very thin shells, basically a straight line up, but they're fairly tall in this case. So starting at 0, going all the way out to a radius of 25, where the shells are very short, but they go a long way around. They have a long circumference. So 2 pi x times negative 0.2x plus 5 dx. And is that going to be a nasty integral to solve? I would move the 2 pi out front and not worry about it, just keep it along, and move the x in and just have a polynomial. So 2 pi integral 0 to 25 negative 0.2x squared, bringing the x in there to square it, to hit that x like that. And from then on out, it's just easy polynomial integration. I want to give a quick homework tip. There's a problem where we're dealing with a parabolic dish, and there's a formula that's x squared over 25 plus 1. It's not x squared plus 1 over 25. So I'll say this one is a yes. It's not that, and it's also not x squared over 25 plus 1. So if you think about order of operations the way the problem is given, the 25 is in the denominator, and then the plus 1 happens after the division, because multiplication and division come before addition and subtraction.